Good morning, students. This is our second lecture of partial differentiation. So, in the first lecture, we saw how to differentiate partially. Means when the given function, it is function of two or more variables. Say z is function of x and y. We solved some problems. We saw the basic concepts. That is, while differentiating with respect to one variable, rest all variables are constant. Means if you have z is function of x and y, while finding derivative of z with respect to x, y is a constant, and while finding derivative of z with respect to y, x is a constant. And this concept can be continued even if it is function of 3, 4 or any number of variables. Now in the second part, we are going to see how to find this partial differentiation of composite functions. In every lecture, I told you all these lectures are just to understand the concepts. I'm not going to discuss plenty of problems, but you have to understand the concepts. That's more important. So please pay attention now. Composite function. First of all, what is the meaning of composite function? Let's have reference of what you have already studied. You have studied one variable function in which you have, say, if y is function of x and x is some function of t. Means as an example, if y is function of x, that is, say y is x square, and let's have x is some sine t. So, if I actually put in place of y sine t, what am I going to get? Y is sine t square. Means in short, we are getting y is function of t. Now, because y is function of t, obviously we can find dy by dt, and you know this is the answer. Now, here it was a simple example. We can already substitute, we have substituted here, we can actually substitute this x here, but it may not be always possible or maybe very complicated. Like if I give you, say y is function of x, say y is x square plus 2x plus 1, and I have x is sine t minus t square plus 3t. Now in this case, if you actually try to substitute, then it will be very complicated. But still you can just see y is function of x, x is function of t, so y is function of t, and we can always find derivative of y with respect to t, and you have seen it, this dy by dt is dy by dx into dx by dt. Now exactly same way, we are not going to study this, we are going to study functions which are of two or more variables, that is partial differentiation. But I just gave this example to understand the concept, it's similar to this. Now what we are going to do here, see the similar concept. If we have z is function of xy, and say x and y are functions of u and v. So again you can see z is function of u and v. Clearly z is function of u and v. Just like this we can find derivative of z with respect to u. How it can be found out? See, when I want to find now daba z by daba u, see properly, z is function of u, but it is via x. So I have daba z by daba u will be daba z by daba x into daba x by daba u. Just see what I have done. Moreover, it is also function of u via y. It's not just function of u via x, it's function of u via y also. So I will have plus daba z by daba y into daba z by daba u, and daba y by daba u. Exactly same way you can find this derivative of z with respect to v. Again you can see it is dabba z by dabba x into dabba x by dabba v plus dabba z by dabba y into dabba y by dabba v. Means what we are saying, z is function of v. First it is via x. So dabba z by dabba x into dabba x by dabba v plus it's also function of v via y. So dabba z by dabba y into dabba y by dabba v. Now this I told you when we had here z is function of xy, xy is function of u, v, w. Maybe now if we have z is function of u, v, w, three variables, and this u, v, w are functions of x and y. Now exactly same way z is also function of x and y, and now when I want to find out dabba z by dabba x, again see properly, z is function of x via u, via v as well as via w. So exactly similar way, what formula you expect here, try it your own. Dabba z by dabba x would be first of all dabba z by dabba u into dabba u by dabba x, dabba z by dabba u into dabba u by dabba x plus it is also via v. So dabba z by dabba v into dabba v by dabba x, and lastly its function of x also via w. So it is dabba z by dabba w into dabba w by dabba x. I hope I am clear. And exactly same way you can see it is function of y also. And now this I am leaving for you. You can always get what will be dabba z by dabba y. Exactly similar way, dabba z by dabba u into dabba u by dabba y plus dabba z by dabba v into dabba v by dabba y plus dabba z by dabba w into dabba w by dabba y. And this way you can extend up to any number of variables. So this is what the idea of composite function. Composite means function of some variable via some other variables. Now using this we can solve as an example few problems, but before that one very simple example I will give you. Say suppose we have just very simple to understand the concept. Let's have z is log of x square plus y square, and say I have x is u plus v, y is u minus v. Before you find, means my question is say find dabba z by dabba u and dabba z by dabba v. When you say this kind of problem say in any exam, then first thing, the moment you see dabba, means you have to understand it is function of two or more variables. So if you see you have to find dabba z by dabba u, it is function of u and other variables also, maybe 2 or 3 or 4, whatever. If it is directly function of u, you can find dabba z by dabba u keeping rest all variables constant, which was explained in the previous video. Now what I am going to tell you, when you want to find dabba z by dabba u, so look at the function. Is it directly function of u? No. What we have here, we are given z is function of xy and x and y are functions of u and v. It's not directly function of u or v, and that gives us the hint it is function of composite rule. This is composite function. So before you start, always you write the data in short, that is z is function of x and y, and x and y are functions of u and v, and you are asked to find dabba z by dabba u and dabba z by dabba v. So again it's not direct function of u, so we have to use this formula. This is called as chain rule. We have dabba z by dabba u. You can see it is dabba z by dabba x into dabba x by dabba u plus dabba z by dabba y into dabba y by dabba u. So we have dabba z by dabba x into dabba x by dabba u plus dabba z by dabba y into dabba y by dabba u. And now z is log of x square plus y square. That gives me what is dabba z by dabba x. Now remember dabba z by dabba x, just give few seconds and think first who is constant and who is varying, so you will avoid the mistakes. You are finding derivative with respect to x and you can see this is function of x and y. So obviously y is a constant. So keeping y as a constant, derivative of log of x square plus y square, everyone knows it is 1 upon x square plus y square into again derivative of this with respect to x, which is 2x. So we are going to have here, this is 2x upon x square plus y square into dabba x by dabba u. Now see what is your x. X is u plus v. So dabba x by dabba u is 1 plus. Now we want to find dabba z by dabba y into dabba y by dabba u. So same way with respect to y, our derivative will be 2y upon x square plus y square and dabba y by dabba u is again 1. So I will have here 2y upon x square plus y square into 1 and this gives us 2 into x plus y upon x square plus y square. And exactly same way you can find dabba z by dabba v. It's again now I can do quickly dabba z by dabba x into dabba x by dabba v plus dabba z by dabba y into dabba y by dabba v, and I hope you all can do it now. Dabba z by dabba x, you know it is 2x upon x square plus y square and dabba x by dabba v is 1 plus dabba z by dabba y is 2y upon x square plus y square and dabba y by dabba v is minus 1. So again similar way what we are going to get is 2x upon x square plus y square into 1 plus 2y upon x square plus y square into minus 1, and this is 2 into x minus y upon x square plus y square. That's it. So this was just very simple example just to understand the concept of composite function. And now we'll solve one or two problems. Let's have a problem like, say we are given z is f of x y with x is r cos theta and y is r sin theta, and our question is prove that dabba z by dabba x whole square plus dabba z by dabba y whole square equal to dabba z by dabba r whole square plus 1 upon r square into dabba z by dabba theta whole square. Now just look at this. Whatever is asked to you, as usual, now it's very common to everyone, whenever we want to prove something, the normal procedure is we evaluate LHS, then we evaluate RHS and we see both are equal. When the simple thing here you all can observe is, first we'll find derivative of z with respect to x, we'll square it, derivative of z with respect to y, square it, add them, keep it aside. Same way, derivative of z with respect to r, square it, derivative of z with respect to theta, square it, multiply by 1 by r square, add them, keep it aside, and both the sides should be equal. That's a very simple logic what you can understand in the first side. Now, before you actually start for differentiating, as I said, when you have to differentiate, please check the function, given function z is function of how many variables, 1, 2, 3, etc. If it's 2 or more, you have to see who is constant and who is varying. That is a must. Secondly, what we have to see when we want to find dabba z by dabba x, you have to see is z function of x directly or via some variable. If it's directly the function, directly start differentiating. If it is via some variable, what you have to do? You have to use the chain rule, that is rule of composite function. So before we start, we have to see all these things. So first always write a given thing. As I told you in the previous problem, you can see here z is function of x and y are function of r and theta. Now here, most important thing. See, if we start solving LHS, you know one way start solving LHS, go on solving, you will get RHS. One way start solving RHS, go on solving, you will get LHS. Or one way solve LHS, keep aside, solve RHS, keep aside, show both are equal. These things everyone knows. Now, if we start solving LHS, come on, what's our LHS? It is derivative of z with respect to x. Now look at the problem. We are given z equal to fxy. Means we are given z is function of xy. But we are not given what is that function. See properly and understand my point. We are just given z is fxy. Means z is function of xy. That is the only meaning of this statement. But it doesn't give us what is that function. Is it sin x plus y? Is it x square plus y? Is it x minus y? What it is, we don't know. And that's the reason we cannot find dabba z by dabba x. Neither we can find dabba z by dabba y. Again I am telling you, see properly, especially in this problem. When we want to find this, see we are given z is fxy, means we are simply given it is function of x and y. We are not given what is that function. So we cannot find LHS. And that's the hint. It tells us start with RHS. Now let's see, can we find RHS? What is RHS now? We need dabba z by dabba r and we need dabba z by dabba theta. Now what is there with us? Z is function of xy, x and y are functions of r and theta. So all of us know now z is function of r and theta. It's via x. So again, what you have? Dabba z by dabba r. That will be dabba z by dabba x into dabba x by dabba r plus dabba z by dabba y into dabba y by dabba r, and same way you will get for theta. Now let's actually write down it. We are going to find dabba z by dabba r. Okay. Now to find dabba z by dabba r, now what I will do? I will rewrite for you. What is given to us is z is f of xy, x is r cos theta, y is r sin theta. Just I will write this. What we have to prove is dabba z by dabba x whole square plus dabba z by dabba y whole square is dabba z by dabba r whole square plus 1 by r square dabba z by dabba theta whole square. And as I explain you, we have to start with RHS. So let's start with RHS. I will try to find dabba z by dabba r, and for that now we had the diagram. In the previous page we had dabba z by dabba r. This is dabba z by dabba x into dabba x by dabba r plus dabba z by dabba y into dabba y by dabba r, which will be, now as I said, dabba z by dabba x we cannot find, so I will just write dabba z by dabba x into dabba x by dabba r. Before you take derivatives, again I am telling you, just wait for few seconds and see properly. X is function of r and theta. So when you are differentiating with respect to r, your theta is a constant. So your dabba x by dabba r, understand the previous video I told you, theta is constant. So keep it as it is. Derivative of r with respect to r is 1. And we are going to get simply cos theta And exactly same way this dabba z by dabba y, I'll keep as it is, and dabba y by dabba r, that will be sine theta. Now look at this, what we want. Okay, we found dabba z by dabba r, we want its square. So now my next step would be dabba z by dabba r whole square, which will be it's a plus b whole square. So dabba z by dabba x whole square cos square theta plus dabba z by dabba y whole square sin square theta. You know a square plus b square plus 2ab, that is 2 cos theta sin theta dabba z by dabba x into dabba z by dabba y. This we found out dabba z by dabba r whole square. Now we'll go for dabba z by dabba theta. So now let's see what will be dabba z by dabba theta. Now exactly same way you can understand it now. Dabba z by dabba x into dabba x by dabba theta plus dabba z by dabba y into dabba y by dabba theta, which will be again now same way. We have to keep dabba z by dabba x as it is. Dabba x by dabba theta. Look at this, our x's are cos theta. Now again with respect to theta, r is a constant, it remains as it is, and derivative of cos theta is minus sin theta. So dabba x by dabba theta will be minus r sin theta, and I will get here minus r sin theta plus exactly same way now this is as it is, and dabba y by dabba theta will be r cos theta. Now again what we want, dabba z by dabba theta whole square into 1 upon r square. So let's have dabba z by dabba theta whole square, again a plus b whole square. So what we will get, dabba z by dabba x whole square r square sin square theta plus dabba z by dabba y whole square r square cos square theta. You can say it's minus sign here, so it will be minus 2ab minus 2a into b. So it is minus 2 r square sin theta cos theta into dabba z by dabba x into dabba z by dabba y. This is just a minus b whole square I have used. Now what we want is 1 by r square dabba z by dabba theta whole square. You can see r square is cancelled and that will get cancelled from every term, and what we are going to get is dabba z by dabba x whole square sin square theta plus dabba z by dabba y whole square cos square theta minus 2 sin theta cos theta dabba z by dabba x into dabba z by dabba y. This is my number 2. See properly again what we want. We want to find out dabba z by dabba r whole square plus 1 upon r square dabba z by dabba theta whole square. Look at this, dabba z by dabba r whole square, and you can see that is 1 upon r dabba z by dabba theta whole square, and when you add them, see this term is cancelled, minus 2 sin theta cos theta, here it is plus 2, and when you add these two, dabba z by dabba x whole square cos square theta, here dabba z by dabba x whole square sin square theta. So dabba z by dabba x whole square is common. What is left in the bracket is cos square theta plus sin square theta, which is 1. Same way here dabba z by dabba y whole square is common. What is left in the bracket is sin square theta plus cos square theta, which is 1. And so when you add these two, what we are adding, dabba z by dabba whole square plus 1 upon r square dabba z by dabba theta whole square. You all can try your own, but still I will complete this. Dabba x z by dabba x whole square plus 1 upon r square dabba z by dabba theta whole square. As I told you, after adding we are getting dabba z by dabba x whole square plus dabba z by dabba y whole square, and whatever you have obtained, you can see that is the LHS. And so this is our LHS. So we have LHS equal to RHS. I just told you why I started with RHS. So this was just illustration of concept of composite function for partial differentiation. So I hope you understood, and then we'll stop for this, and next video we are going to see application of this partial differentiation, where we are going to see what is homogeneous function and what are the Euler's theorem and the corollaries for homogeneous function. So thank you very much and goodbye till then.